Hi, this is John Weber with Schneider Electric. Thank you for joining us. We're going to be talking about lithium-ion battery solutions for the Conext XW+, Conext SW, as well as the MPPT 60 and 80 charge controllers. So please relax and join us for the next hour as we talk through this solution. Because lithium-ion is an up-and-coming technology that there is a lot of interest, we're going to go into a few different subject matters to make sure that we really cover as broad a range of information that we can throughout this presentation. So there's a lot of interest about where lithium-ion makes sense, why it's making more sense for just more common residential installations, as well as sort of time of use. So we'll get into some of the value proposition that comes with lithium-ion. Of course, there's a lot of different chemistries and technologies that go into lithium-ion, as well as exactly how that battery management system is going to help make sure that that system stays safe and meets our expectations. So we'll be diving a lot deeper into exactly what lithium-ion does. Of course, lithium-ion is a different technology. If you're very used to, say, using just a standard flooded lead acid or AGM or gel battery, there are some design considerations that we have to take into account and a few things that may surprise you along the way. And then finally, we'll talk about exactly the Conext product line, in particular the XW Plus, and just the compatibility with lithium ion. And we'll finally touch on some of the projects that we've partnered with and done ourselves here at Schneider Electric. So we're very much looking forward to doing this presentation with you. Perhaps one of the most important things when working with power electronics, of course, is that we need to stay safe. Within the inverter solutions, as well as on the DC side, you can be exposed to some very high voltages, both on AC and DC current. And some parts get abnormally warm, so careful when you're working with a solution to let it properly cool down. We talk about lithium ion specifically. We need to make sure that we are working with a lithium ion pack that does come with a battery management system, isn't just a bunch of cells strung together. When we get one step further past that, we want to make sure that we only use batteries and energy storage systems that have been certified by either UL or somebody like IEC. So when we look at 1973 and 62619, those are both tests through UL and IEC to make sure that the battery management system has been used correctly, as well as is able to turn the system off or disconnect it during critical moments if something goes wrong. With UL 9540, we're talking about that a complete solution works together. So some of the manufacturers that we're going to be talking about today have actually integrated in charge controllers, inverters, and batteries all into a single box. And so if you're looking for the right kind of manufacturer, definitely make sure that you're looking for 9540. And then for shipping, want to make sure that we have the UN 38.3. Just simply make sure that that battery management system is certified to be shipped across the United States. Before selecting a battery pack with the Conext XW plus the Conext SW and those MPPT 60 or 80 charge controllers, definitely want to make sure that you work with the battery manufacturer directly on settings, as there's a lot of different battery management systems and, of course, a lot of different chemistries out there. So we want to make sure that you guys have the best settings when hooking a system up. There is no stock settings for these solutions, so definitely make sure you are talking to the battery manufacturer and making sure that your application falls well within the applications that they've designed that battery management system, as well as the batteries themselves for. So far, when we look at lithium ion and exactly its current place in the world, we're seeing that it is what we consider a disruptive technology. We've seen where electronics, and in particular home consumer construction equipment, have switched from nickel metal hydrides, and they're going to lithium. As well as automotive, we're seeing that these products have started out with something like flooded lead acid back in the 80s, and we've seen it move forward through NiCads all the way up to lithium ion as well. So we're definitely seeing that more and more of this production is going up. So how does that affect the overall cost for renewable energy, and how does that fit in? So when we look at lithium ion with renewable energy, we can see that just like PV, as production continues to climb in the PV sector, prices continue to fall. We've seen a sort of a slope of a 1-to-1 or a 2-to-1, so that for every cumulative megawatt hour that we're producing, the prices are continuing to fall. What does that mean exactly for the next few years? That means that by about 2018 going into 2019, we should see that prices flatten out with lithium ion to somewhere between $200 and $250 a kilowatt hour, just simply because of the volumes that are out there. And eventually we see it sort of bottoming out or coming to a rest somewhere in the $150 kilowatt hour, which, by the way, is about what today's lead acid costs are. When we look internationally at places where we've seen lithium ion already being installed into renewable energy places or renewable energy systems, like in Australia, typically about 3 out of 10 battery systems are installed using this solution in Australia. As the United States, as well as places in Hawaii, continue to adopt time of use, we're going to see more and more lithium ion batteries getting more traction, and as well as more electric vehicles come into the market. That is going to help as well drive those prices down. Since about 2011, Schneider Electric has been working with lithium ion partners and installing lithium ion through a variety of different solutions. With SunVerge and Kokum, we can see here on the left-hand side, what they did was about 300 to 400 new homes for backup management, self-consumption, as well as virtual power plants for on-demand response using a nickel manganese cobalt. Schneider directly partnered with Saft to do about 300 homes on a small island grid to stabilize 3 megawatts of PV on a 10 megawatt grid, essentially being able to push power onto the grid when a high altitude cloud began to shade over that PV array. This deployment was very, very successful, using a little bit different chemistry than what you're going to typically run into, which is the nickel cobalt aluminum. For SolarCity and Tesla on the right-hand side, this system was set up for SGIP program, really as a retrofit to the existing grid tie inverters that they had already been installing in great quantities. If you're from California, you're familiar with what I'm talking about. For this solution, it was about 400 to 500 homes that were installed during that time. With the other partners for the United States, we have Simplify, Adara, which used to be called Juicebox, Iron Edison, and of course Tesla. For Canada, we have Discover Energy Group based out of Vancouver. In South Africa, we have Blue Nova as well as Freedom One. For Czech Republic and the UK, we have Fitcraft Energy. And in France and the US, we have Saft. And finally, in Korea, we have Kokum. So why did all these partners choose the Schneider Electric Conext line? It's because we produce the most compatible solution with lithium ion. Between the communications and just the open settings that can be set up within the system itself provides the greatest amount of compatibility, if you will, to a system. So let's learn a little bit more about how this all comes together. With the value proposition for lithium ion, there's really 6 primary things we're going to be covering. The first 3, of course, is that it is compact, has an excellent cycle life, and that there is a third-party brains inside, if you will, with the battery management system. When we look at being compact, we look at just exactly how small a lithium-ion solution is compared to a more traditional lead acid. Not only are we talking about, like with the LG Chem, something that's the size of a briefcase with 8.8 kilowatt hours, which gives us a lot of versatility of where we want to put it, either up on the wall or into a confined area. When you look at lead acid within that same capacity, we have in this example, a Trojan L16s, and the same number of amp hours is going to take up almost 4 times the amount of volume. So the other part with this is just simply that we just don't have as many connections to make compared to the lithium ion, which really only has one connection, the positive and the negative. For flexibility, we're really looking at what the easy logistics are. It's not going to weigh the same amount. We can see here 75 kilos versus almost 450 kilos with those L16s. So you're looking at a burly man or a 2-man lift to get those batteries installed. As well, again, we just mentioned that you can put it into fairly confined areas and get it up mounted off the floor, so that typically when you look at a flood lead acid battery, those type of batteries are going to end up inside of some sort of protective box to help manage venting. With everything else that goes with that, it's just a larger space even above and beyond what the physical space of the energy storage is. As well, one of the things that I like to say about these good-looking solutions with lithium ion is they do have a bit of spousal approval. So oftentimes when we're looking for a really nice setup. The Schneider Electric products are really, really good looking products. And then you look at kind of traditional lead acid batteries, and they just don't have that same polish that can come with something like a lithium ion solution. The LG Chem Resu 10 battery is a really good looking solution. And then finally, that versatility again comes with just where we want to put it. If you want to put a traditional lead acid battery outside, you're going to need to build basically its own structure. When we look at the lithium ion, though, we have several partners and manufacturers that we've worked with in the past that are already producing an outdoor rated box. So that makes for a really nice together solution. Talking about cycle life, we look at here, and I apologize, it can be a little hard to see, but we have a yellow line and a darker line within this graph. The yellow line is the cycle life for lithium ion. And just like a traditional lead acid battery, the deeper you dip into the batteries, with each cycle, the less number of cycles we're going to get. So there is an ideal number of cycles that we can get out of it. Typically, most manufacturers are going to say about 80% depth of discharge is that ideal number, and then we're getting close to 10,000, and at 100% we're getting 3,000 to 5,000. Comparatively, of course, with lead acid batteries, this is a significantly smaller number. And so when we talk about kind of the value proposition with these small commercial systems in particular, if these batteries are cycling a couple of times a day, or the remote location just requires going out there with very expensive equipment, one of the value props is just simply that we're going to get more cycles out of that system, so we don't have to replace these batteries as often. As well, when we look at just the replacement, 10 years, again, a great way to know that we're going to get a lot more life out of that system. And when we run into conditions like an off-grid solution with some pretty conservative generator runtime, or maybe no generator, a very resilient partial state of charge means that we're able to charge those batteries as much as we can with solar. And it doesn't really matter if we're taking on average 50% depth of discharge. It doesn't matter if for a couple of days we only got that state of charge up to 80 or maybe 90%. Whereas with traditional lead acid, that is a recipe for disaster, and will eventually sulfate and destroy those batteries. Perhaps the most important thing, and the thing that I love about lithium ion, is those brains inside. We talk about the battery management system. What we're really talking about is the capacity for the batteries to sort of advocate for themselves when things have gone a little sideways. As installers, we definitely know that customers, the solution is going to grow and change over time. And so having a way to have the batteries actually self-protect so that we don't discharge too much can be a huge cost saving and value add to using lithium, because it does self-protect against those over voltages, overcurrent situations. And if we, for some reason, get a very high temperature, the system will self-protect as well. That also means that with battery management systems, and with some of them, they're actually able to communicate with the inverter. So we're actually going to be able to talk to that inverter and tell the system what its state of charge is and its state of health is. As well, with the battery management system, oftentimes we're going to find, especially in the high quality ones, their own data logging so that we can see exactly how that system's been used. That not only protects you, the installer, if you do have a warranty issue, but helps you understand how that system's being used or how the battery management system thinks that system's being used. And in some cases, again, if we're able to communicate with the inverters through, say, ZAN bus or other methods that we'll talk about here in a little while, you can actually send commands to the inverters and have them change their parameters either for charging. So we're always making sure that system's getting charged at exactly the right amount time and again, which again is going to guarantee and make sure that we get as absolutely much out of that system as we can. When we talk about lithium ion, we're also talking about that it comes as an integrated solution. When we compare that to a traditional lead acid battery, typically we're talking about smaller building blocks to build up to, say, 48 volts or even 24 volts. And so when we have already a 48 volt system in a box, we have reduced connections in between each unit. So if we have multiple strings, we're not talking about if a 2-volt flooded lead acid solution becomes 24 and 48 connections with 2 strings. With lithium ion, we're really just talking about 2 strings to finish out that solution. As well, because it is, again, that integrated solution. Everything is coming together as one package. We don't really need anything beyond what the manufacturer for the lithium-ion solution provides. So as simple as either hanging it on the wall, or in some of the solutions like we see from a company called Simplify, they have a very simple bolt to the wall on a couple of studs, little shelf unit to hang their batteries up on. As well, when we talk about integrated, that battery management system we talked about in the last slide really starts to shine with this built-in shunt, with built-in battery monitor, and so we're actually able to see that system and the power flow throughout it. The other nice thing is with a lithium-ion solution, because we have that battery management system in between, if for some reason, even on the best day, we can have a bad day and accidentally cross those positive and negative conductors going to the inverter, what we're going to get is the FETs blowing on the inverter itself. With lithium ion, the system actually self-protects faster than what we're going to accidentally blow those FETs up with. So it's just another level of protection and making sure that system goes in nicely. And we've talked a little bit about cycle life, but here's where it really starts to count. Because lithium ion has 5,000 to 10,000 cycles, we have a lot more opportunity to bring in another setup of storage. So let's say some reason somebody installs a certain amount of storage, the system needs to grow, instead of having to build a parallel system like we would with traditional lead acid batteries, because we only get a couple hundred cycles before those two systems would deviate too much, so we wouldn't be able to add any more storage. With lithium ion, we have that high cycle number, and so we're actually able to bring in more storage without affecting the overall life of that system. So maybe after a year we decide to bring more storage in, we can still do that with lithium ion. With traditional lead acid batteries, we're going to see a degradation of that system, and it's not going to get we're not going to get the best bang for the buck out of that solution. For high C rates, the interesting thing with lithium ion is that we can discharge at exceptional C rates. And when we do that, compared to a lead acid batteries are going to see that voltage start to drop very quickly, as chemically the batteries are trying to keep up. With lead acid batteries, they're not going to be able to provide that C2 rate and provide the same number of amp hours as though it were over a C20 rate, which is typically what you size a lead acid battery for. Lithium ion, though, if it's a C2 rate, typically a C20 rate, it doesn't matter. They're going to be able to provide that current, and they're also going to be able to provide that voltage without seeing it kind of nosedive, if you will, at the end. We'll have an image later on to go into that as well, because we have those C rates, both high C rates for both charging and discharging. When we look at charging, that allows us to charge from an AC source much quicker than a traditional lead acid storage solution. So that means that our generator run times are going to reduce, the number of hours we're putting onto a generator is going down, or if we have intermittent AC from the grid, we're going to be able to rapidly charge those batteries and get more into that system than we could with a traditional solution. And then finally, one thing that was pointed out to me that's really interesting is that we're starting to see a lot of DC loads coming in there with DC lighting, because then we don't have to convert it to AC and then back to DC again with an inverter, and then locally with a wall wart, if you will, to a and the all the electronics installed, we have to install When we talk about understanding the different chemistries out there, there are a lot of them. But for stationary storage, really, there are kind of three of the most common is lithium cobalt oxide, lithium iron phosphate, and lithium nickel manganese, or NMC. In the center, we have a graph here, but first we'll just cover a couple of terms. For specific energy, we're really talking about how much energy is stored per kilo or per pound. So how dense is that energy? Or for most of us, it's going to be how light per kilowatt hour we get out of it. For specific power, we're talking again about that power to weight ratio, how much current can be supplied out of that system versus how much energy is actually there. When we look at safety, this talks about the chances for something like thermal runaway based on the kind of internal chemistry. And then finally, performance, we're talking about how that system acts in very, very hot temperatures or very, very cold temperatures. When we look at those three different chemistries, let's start first with LCO, or lithium cobalt oxide. Cost for all of these are roughly the same, just depending on really what you're going to need out of that system. So this is, again, why we need to differentiate kind of these three very common chemistries. When we look at the very dense energy solution, LCO makes a lot of sense. We get a lot of power out of it, but unfortunately it doesn't have as high of cycle life, so we're not going to get as many cycles. So if you need something with reasonably safe, has a lot of current, can definitely put the performance out there, and costs the same, then this is where LCO really, really shines. When we look at LFP, of course, again, cost is about the same. Highest average cycle life, meaning that we're going to get the most number of cycles. So cost effective wise, this is one of the best, because really when we talk about the amount of energy storage in there, cycle life is going to be important. This is also one of the safer batteries with the resistance to thermal events and getting thermal runaway. And on average, because it's not as energy dense, it's going to be physically a little bit larger than some of the other chemistries we see out there. For nickel metal cobalt, again, roughly the same. It's got really nice cycle life, and overall the system's going to be a little bit larger than LCO, but again, not as large as LFP. So this is a really simple way. You can see there down in the bottom center, there is a link. Go ahead and type that in if you'd like to see a little bit more about this. This is where this information came from. But you know, at the end of the day, and the thing that's most important about all of this is it doesn't matter about the chemistry if the battery management system has been done poorly or is not there at all. So we need to make sure that when we're looking at the battery management systems, that we're working with people, again, who have gotten the proper UL listing, or working towards that UL listing, or we have confidence that they are or they do know what they're doing to make sure that system remains safe. One other thing that can affect the overall performance of the system is exactly how those cells are manufactured, be it prismatic, which means that it's kind of in a little cube, be it pouch, cylinder. Those can affect performance as well, and how it all goes together. So it's more than just the chemistry is really kind of the point of this slide. It's a combination of a lot of different things. Chemistry, manufacturing process for the form factor, and of course, the battery management system. As we just spoke about with how things are coming together, be it in a pouch or in a cylinder or prismatic, there's also a lot of different flavors and form factors that are available from different manufacturers. We like to think of it as having a bit of a free spirit, just simply because each one's kind of coming up with their own look. With Simplifier, we're looking at something that's about the size of a golf cart battery. For Madera, something around the size of a mini fridge. When we look at the Freedom batteries, they're about the size of a small briefcase. And with Discover, they're looking for a similar footprint to like 8D batteries. With Iron Edison, these are large building blocks with a lot of storage inside of them and kind of a custom forklift idea. LG Chem is a little bit thick design, and more like the Freedom, whereas with the Hopekek, we're seeing a much thicker design than compared to, say, the LG or the Freedom. The design does have a significant impact on the overall performance. Small form factors do offer a lot of versatility about where it's going to go, where like larger solutions like Iron Edison, it's an indoor rated solution, but you can bring a tremendous amount of storage in there. So why does this all matter? When we look at where some regions are going to be okay with storage on the ground or above, if we look at places like Texas, that region says, you have to have lithium ion up off the ground. And that does make for getting more space. Form factor is going to be changing over the next few years. We're kind of going to expect a sort of standardized manufacturing solution, and how they'll differentiate after that will be up to them. But things are definitely changing, and for right now, there's a lot of different looks and feel to the system. So really check out and spend time talking to the manufacturers about the differences with their batteries and come to your own decision on some of this. For compatibility, there's really 3 different styles of interface that we can have between the Schneider product line and the lithium ion solutions provided by manufacturers. With lead acid replacement, we're really talking about a system that the battery management system manages the power coming in and out of that system, but there is no direct connection. This is a really nice way of doing a direct replacement of aged out lead acid batteries, and makes for programming very, very similar to like something like an AGM battery. The nice thing with the XW Plus is that we have a very broad range of programming parameters, so you can really set that system up how you'd like. When we look at ZAN bus, and this is the one that's pretty darn neat, this allows the battery management system to actually interact with ZAN bus, which means that when you plug it in, it recognizes it as part of the Schneider family. And that allows it to auto-configurate, be able to listen in the appropriate way, and really have full control, not only the inverters, but as well as the MPPT charge controllers. And this is where we can start really using some of the advanced features that we see the XW Plus capable of doing, like AC coupling, time of use. Decisions based on voltage have a really hard time working, and we'll talk about that in a little while. But with AC coupling and starting generators based on state of charge, we know exactly what those are because the battery management system's letting us know. So ZAN bus is pretty neat. Taking that step further, with external controllers, we can communicate through the a new product that's going to be coming out in 2017 in the last half of it. That is the Conext bridge. And this is going to allow us to not only interface and interact with the system, but also it's going to have its own battery troubleshooting and data collection. So it's a third-party system that allows us to interface and collect data outside of the other product. So heaven forbid something does happen, we have another way of actually being able to take that data, troubleshoot it, and really understand what's going to be in that. And with those manufacturers, with LG and Hopekek, that's who we're going to see using the Conext bridge. For clarity, with the ZAN bus down below, we are looking at Discover batteries down below. And then finally, for lead acid replacement, we're looking at using Simplify or Iron Edison. Perhaps one of the largest differentiators between a lot of other energy storage solution chemistries is that lithium ion has some very, very particular ways of taking a charge as well as maintaining its voltage. And for systems that are very, very much built around and have been designed around a lead acid battery, this can create some interesting situations that need to be overcome. So we look here on the left-hand side, we're looking at the discharge characteristics of a lithium-ion battery. And we're looking at about a C3 rate. We can see down below that it starts at 0 hours and moves up to 3 hours and 5 minutes. What I'd like you to note about this is that we can see the voltage coming along and, at 50 15 minutes in, a 90% down to 20%, we're seeing only 1.5 volt difference. That's a 3% voltage drop, which means that over a very, very rapid discharge rate, not only are these batteries able to maintain a very solid voltage and current, we're also able to see that the normal load start and other things like that, which are voltage decisions within the XW Plus, are really going to struggle on how to do this. So we have to make sure that we're using the state of charge from the battery management system to help us make some of these decisions. On the other side of things, when we look at charging, we can see that the voltage very, very quickly climbs in the first 15 minutes from basically a dead battery at 45 volts up to 49 volts. And then from there, we're looking at another very gradual change as we see the current being dumped in at a very, very flat rate. The voltage is going to very stably rise over the next 3 hours. Now, with this particular test, the batteries were basically at 95% full, and they continued to put current in at a constant rate, and the voltage started to rise at an exponential rate. So being able to make sure that we are able to program that system, interface with it, is critically important, as you can probably imagine. Continuously dumping that kind of amperage onto those batteries, and the batteries rising to 80 volts is not a good situation. So just make sure that we're doing this. For generators, you can imagine that being able to put this amount of capacity in very, very quickly makes for one of the best ways to actually use a generator. And again, my argument is do the fuel cost analysis, especially when you put in delivery costs for some more of the more remote locations out there. And lithium ion can start looking very, very attractive just simply because we're able to reduce the maintenance and just general fuel consumption out of that generator. We can maximize the capacity of that generator to the inverter and get it charged absolutely as quickly as possible. And so just a great way to use the overall system to the best advantage that we can. One of the questions that came up about lithium ion is that there are two different ways that the cells actually balance themselves. As we know, there's no perfect way to make sure that every piece of wire is exactly the same length and that the conductivity of all of those is exactly the same. So just like a traditional lead acid battery, lithium ion is going to have a little bit of imbalance between the cells. And there's two ways that we can actually manage that system, and this is up to the manufacturers to put into the system. So when you're talking to them and you're talking about the solution, you really need to understand if it's an active or passive cell balancing. So I'll just go into a little bit more information about that. With passive cell balancing, what we're talking about is that when the current is rising and the batteries are getting full, when a battery is measured as being full at 100% stated charge, it doesn't have anywhere to put that energy. And so what it's going to do is actually use a small resistor to dump that extra energy out of itself while it waits for the two battery packs on the left and right to complete its charge. And so there is that passive balancing really depends on the size of the resistor within that system to finish off and make sure that that system is completely balanced. For active balancing, we're actually moving power from the lithium ion cell that is fully charged, the one there in the center, and moving it out to the two that are on each side that haven't quite completed their charge. So there's a more rapid charge rate that it's available through active balancing. So again, we talked about the advantages of using a generator. If that's what we're looking for in a solution, then that's what we're going to be wanting to use in a situation like this. So talk to the battery manufacturer about the battery management system. Find out if they're using passive or active balancing. There are some clear advantages to active balancing, but you may find that the cost as well goes up a bit. So again, if we're calculating ROI overall, take all of that into account. As we stated earlier, that lithium-ion manufacturers are still kind of free-spirited in their design practices. There's still a lot to be understood exactly about the different chemistries battery management systems, and physical build solutions of these different lithium packs. So we talk about size and max parallel. We need to make sure that the batteries that we're going to be using scale to equal our needs. Some may only stack to 2, and some may have a limitation on the number of kilowatt hours. So make sure when working with the manufacturer, you say I need 20 kilowatt hours, and we talked about earlier that with the high cycle life of these batteries, you're actually able to bring in storage a lot later. Can you bring another 20 in? So make sure you ask that question. Talk about warranty coverage. This is probably one of the most important questions to ask is, I'm going to use it exactly like this. Is my system going to be covered? This is particularly important when we talk about AC coupling or off-grid ready. With AC coupling, some manufacturers are going to say, yes, go ahead. And typically, we're going to find those are the manufacturers whose battery management system's able to directly communicate with these Schneider product line, be it through ZAN bus or within our communications device with the Conext bridge that we talked about earlier. So making sure that that system is able to absolutely talk to the charge controllers or talk to the inverters and begin frequency shifting is going to be important for understanding if that system can do AC coupling. Talked about with energy storage, is it off-grid ready with the active versus passive balancing? Definitely understand and talk to the manufacturer if they're okay with being able to charge and discharge those batteries on a permanent 100% cycle, meaning that there's really no rest period. Where if the generator turns off or the sun goes down, we're immediately going into a discharge period. There is no rest period. There's some manufacturers who will say, no, that will not work. And so therefore, you're really not a good match for off-grid. For cycle methodology, really understand again how your application is going to apply to the number of cycle counts that you get out of it. There's no currently a standard, if you will, for really understanding cycles. So one manufacturer's cycles could be very different than how another manufacturer decided to do their cycles. So again, say, here's my application. How many cycles am I going to get out of that? And make sure that it concurs with what you're planning on doing. For guides and everything else, just make sure that the service department, that it's not a fly-by-night company, that they are an established company. And probably one of the best ways to do it is try calling their tech support even before you have a tech problem. Make sure that they have strong documentation so that you can help yourself if, heaven forbid, something goes wrong. And then finally, again, we talked about those UL listings and IEC listings. Make sure that those manufacturers that you're planning on working with have those. That ensures that the AHJ is going to actually sign off on that system. And as well, because lithium ion is considered a hazardous material, make sure that you have reached out to your insurance company. Heaven forbid something goes wrong and there is a fire. You want to make sure that your insurance company is aware that you've put in this advanced energy storage and that there's not an issue. So again, a good decision-making process is going to really be to reach out to the manufacturer, let them understand your application, how you plan on using that storage. Make sure that they've gone through with proper listings, and then also reach out to your insurance company to make sure that you have informed them of your plans. It could change your premiums. It may not. California, it's actually against the law to do that, but other places it may not be. So just definitely check on some of those issues that are out there and that you are as successful as possible. There's always the question about the safety concerns that come with using an advanced storage solution. We've talked a lot about battery management systems, different chemistries, how they're actually assembled. The next step is to make sure that they are properly assembled, that the system and the application fit correctly. So we talked about those 7 kind of steps in the last slide. this is exactly what we're talking about. So with cell chemistry, any chemistry can catch fire. Some are arguably a little bit safer. The battery management system really is the magic to make sure that if something does begin to go wrong, that hopefully we can catch it before it becomes something that's catastrophic. The quality of the manufacturing of those boxes is very, very important. We can see here that we have two different manufacturers, and they actually had two completely different styles of failure. One was actually a failure of the cells themselves, the individual battery packs, and the one on the right actually had nothing to do with the cells. The lab that the system was being used in was happily still using the power that was coming out of those cells, but unfortunately the battery management system ran into an issue and some of the wiring failed inside of there. So a whole package is the most important package, and that's where when you look at or look for the UL 1973, 9540, and the 62619, all those are going to be great ways of making sure either that the cells themselves or the total system with UL 9540 is going to be a complete solution that is safe. And finally, of course, making sure that the quality of the inverter itself is going to be a good match. And I believe that the Schneider XW Plus in particular is a great match for any advanced storage. And we're ready to match up to a quality battery management system with our open parameters. So that really is what creates a safe system, is all these different factors coming together in a proven way. So we will talk about some of our manufacturers here coming up very shortly. So with Schneider Electric working with any advanced storage, in particular working with lithium ion, it really is a complete solution. From the communications availability with networking on the Conext XW or SW with ZAN bus, to the broad operational parameters from all of our charging products, you're able to really make sure that if they need constant voltage, constant current, or if the system needs just to have very broad parameters for high and low voltage settings, we're able to do that. And the nice thing with the Schneider Electric product line is that we're always focused on improving the systems through hardware and software firmware updates, which means that our compatibility is going to continue to grow, and we'll be able to grow with the changing time. So it's important to understand that the total system is really what makes everything as effective as possible. For the lithium-ion partners we're going to be speaking about, we have 4 that we've selected. We've put them into alphabetical order. And really each one of these manufacturers is going to offer something a little bit different, a little bit unique. And so really, again, we encourage you to reach out to those manufacturers to understand exactly what you're going to need. And if your application is going to match what their product is capable of doing, because each one really does have a different niche that it's going to fill. For Adara Power, which was formerly known as Juicebox, they've been producing lithium-ion solutions since 2013. They are ZAN bus integrated, which means that for AC coupling, they can do that as well as DC coupling. Some of the really neat things that they're capable of doing is they have a really nice single install box that can be hung on the wall with enough room, if you notice there, for your surfboard. One limitation is that the building blocks are an 8.6 kilowatt hours or a second unit for 17.2 kilowatt hours. Again, double check with them. Things are always changing, so their capacity may change since the time you listen to this webinar, so just reach out to them. The really nice thing with this is it is outdoor or indoor rated, which means that it gives you a lot more options. If space is limited, because it is a significantly larger box than, say, what the XW itself is, it may make sense to just mount it on the other side of the wall. Auto setup with ZAN bus is probably one of my favorite things, which means that it will communicate and set that system up and change those parameters on the fly as it's needed. High cycle life means that it can do peak shift or just be there for backup. Cellular connection allows you to use their software as well as Schneider Electric software to see how that system is working overall. It really is designed to be lifted by just 2 people and provide a tremendous amount of power with up to 4,000 cycles and a 10-year warranty. So feel free to reach out to Neil. He's excited to hear from everybody who's got a project. The chemistry that they're using is that nickel metal cobalt, nickel manganese cobalt for their solution. For Discover Batteries, they've been around since 1949 with producing standard lead acid batteries, and now have started producing lithium ion or lithium iron phosphate. They are as well ZAN bus enabled, which allows them to do that plug and play compatibility. Just plug it in and the system actually starts talking to it. With their capacity of bringing up to 10 units into a solution means that you can do 66 kilowatt hours of storage, and with that integrated battery management system, they can dynamically control that system and again be able to do AC coupling. And they use the lithium iron phosphate, which means that they provide a much more stable chemistry than compared to some of the other chemistries that are out there. If you are looking for sort of an unbiased example of what they're capable of doing, this is a good company to reach out to, because they have been selling and will continue selling lead acid batteries for some time, as well as lithium ion. They can give you kind of a compare and contrast, help you decide if maybe lead acid still is the right direction to go, or to consider using lithium ion for that next project. Iron Edison out of Lakewood, California also uses lithium iron phosphate. They have a unique solution in the fact that they can provide from 9 to 500 kilowatt hours of storage, a very, very large system designed and assembled in the United States. And they do have a long-standing history with being able to help design systems as well. They're kind of an integrator for lifetime technical support, as well as just being able to provide, again, very, very high capacity solution with those prismatic cells. It's just an amazing number at 500 kilowatt hours. Brandon Williams, the owner, feel free to reach out to them through info@ironedison.com with a 7-year warranty, a pretty darn good solution. So you have a lot of energy storage needs. Iron Edison is as far as I know, one of the largest providers for single solutions with, again, that 500 kW of storage. Simplify Power, based out of Ojai, California, also uses lithium iron phosphate. With an integrated battery management system, this allows you to do a direct replacement of old lead acid batteries. There is no direct communication with it, so this wouldn't be a system that you necessarily want to do AC coupling, but again, always reach out to the manufacturer to learn more. At 98% round trip efficiency and 10,000 cycles, offers some of the best numbers that I've personally seen. Great operating temperatures, so this system can go just about anywhere into North America that you would need. And with the no active thermal management, it means you just simply use the system as it manages itself, and does a really nice job overall. Please feel free to reach out to Ben Windermere at benw@simplifypower.com. They are all very excited, each one of our manufacturers, to see systems go in. If you have any questions, please feel free to reach out to me, and I can help either answer them or find the person that will help answer them, as well as if you already know what you need, feel free to reach out to our sales department. Colin Carroll is happy to answer any questions and connect you with any of our manufacturers, either on the lead side or the lithium ion. One thing I'd like to invite you to do is head over to the Schneider Electric website and check out our support, as well as our opportunity to give some feedback. We want to hear stories about you guys and from you guys. Tell us a little bit more. Hopefully we'll be able to highlight some of the neat things that our installers and integrators are currently doing out there in the world. I'd love to hear from you personally as well. So feel free to reach out if you'd like to. And until next time, we'll talk soon. Thank you.